This is problem number 4 in the textbook. In chapter 12, it reads, an ocean fishing boat is drifting just above a school of tuna on a foggy day. Without warning, an engine backfire occurs on another boat, which is 1 kilometer away. How much time elapses before the backfire is heard by the fish and by the fishermen? So I've made a quick sketch of it. We've got two boats. We've got boat number 1, which is right here, and it's going to be the one that backfires. And we can see that there are two kind of recipients of the backfire, if you will. There's a school of fish, and then there's also fishermen on another boat. And both of those distances are exactly the same. So in other words, it's 1,000 meters or 1 kilometer from where the backfire occurs. So we've got 1,000 meters here. And this is where the backfire occurs. So I'll make kind of some sound pulses here. This is where it happens, and the question is, how much time elapses before these guys hear it, and then the school of tuna underneath the boat hear it? They're just under the boat, so we can largely ignore over 1,000 meters. Of course, this is not to scale. The fact that this is actually going to be slightly larger than 1,000, but by such a small amount. Okay, let's go ahead and solve the problem now. We're simply going to use the very simple idea that velocity is equal to distance over time, and therefore time can be resolved by dividing distance by velocity. And so in case number 1, where I'm dealing with the fishermen, so let's solve this problem first. We're dealing with these guys, so we're going to be solving for the time experienced by the fishermen. It's going to be the 1,000 meters divided by the speed of sound in air, which is, you can just leave it as 343 meters per second. Now, of course, there's a time-corrected formula for the speed of sound, temperature-corrected formula for the speed of sound. So the speed changes a little bit. V sound is equal to 331 meters per second plus 0.6 T, where T is the temperature in degrees Celsius. At 20 degrees Celsius, which is about 68 Fahrenheit, that yields that number 343 meters per second here. So that's the number that I'm going to use. You'll also see 340 used quite regularly. So here we get 2.9 seconds. So the fishermen hear this 2.9 seconds later. Now let's do the whole thing again, except now we're going to do it for the fish. And we should see that, you know, the equation starts the same, and we're still going to get time is equal to distance over velocity, and the distance is still 1,000 meters. However, the speed of sound in water is much, much faster. It's 1,560 meters per second. This number would have to be given to you in a problem. It is in the textbook. And once you run that through your calculator, you get 0.64 seconds. So the purpose of this problem is, A, to kind of see that you can still use, velocity is equal to distance over time, some simple kinematics, constant velocity formulas to solve for these things, but also to see what a radical difference the time is based on the difference in these two speeds in water and in air.